We've now officially begun, and we're carrying on from. This is the point we're going to start from where we kind of ended last time. I mean, I completed tuberculosis. Very interesting. I mean, there's. I know it's a lot of material to digest with all of these chapters, and respiratory. Again, you're going to see more respiratory illnesses, and particularly many of you pneumonia in a hospital setting, much more than you want to see. This is one you're unlikely to see, but it's interesting because of just we see it comparatively rarely. The Legionnaires, so named because in 1976, which was the bicentennial, and now we're at 250 years ago, obviously, was now, and that was the summer. And this is what happened. It was in Philadelphia, and this was, I think, about 17 to 20 of these. I'm sure that nobody wants in. So let me just do a temporary escape. We have people online. Oh, there they are. You're glad you're here. And so to get back to the saga about this, and of course, this is another one. Yes, I was there. It happened. If you're familiar with the Rittenhouse Square area, Philadelphia, a lot of people have seen the Liberty Bell and that type of stuff. That's toward the Delaware River, and that is if you go in to that historic area and you go upward, Rittenhouse Square is about 7 city blocks above that. Rittenhouse Square is like 15th and maybe Walnut, and Liberty Bell is 6th and Arch. Having spent 6 years in Philadelphia. Long story short, Rittenhouse Square is this very old area that has very similar buildings, and the analogy would be like our William Penn Hotel, if you're familiar with downtown. Very, very similar kind of buildings, built around the same time. I would dare say circa Civil War, maybe a little before, a little after. Old buildings are grandfathered in, meaning they had all. If you ever saw these old, they had all the old crawl spaces, and you had basically the ventilation ducts, the water ducts, the electrical lines. They were dusty, they were dank, and everything. So the old hot water would drip, and there'd be a lot of dust there. And that turned out to be the perfect culture plate for this particular organism, which is a bacteria. Here's the story. So the Legionnaires, that was 76. They actually had World War I, World War II, Korea, Vietnam era vets in an American Legion. And if you're unfamiliar what happens when you're in a convention, you basically have this giant set of rooms that they can partition off. They have lectures, and they'll partition them off to have meals, and they'll partition them off again for people to sit around and swap stories in the evening and have a few drinks and things like that. It turns out when this came out, people were, a lot of them, mostly older, were getting terribly sick. And it wasn't just respiratory, it was gastrointestinal. They were dying. And they thought that somehow this had been a reoccurrence of the dreaded Spanish flu of 1918 and 1919, the largest single infectious disease killer that we are aware of historically. Over 100 million people back then over that season. It turned out it was not that. In order to see what virus it was, because they were sure it was a virus, they took the lead viral investigator for the Commonwealth of Pennsylvania, a guy named Dr. Jay Satz, who was my virology instructor, by the way, how I knew this. And I was very familiar with the hotel because we used to have, pardon me, our honor society, our anatomical honor society meetings there, just saying. So I knew exactly where this all happened. And it turned out he couldn't find it. It wasn't because it was because it wasn't a virus. It turned out to be a relatively common bacteria that grows under those kinds of circumstances. Dusty areas, warm, moist. It slightly grows better in warmer, moist areas, so to speak. And all of these things look like this terrible flu, like one of our severe, when you hear about swine flu and bird flu and these really nasty epidemics we're so worried about, this is it. Same kind of things we saw with things like COVID. So, and this is what happened. About 25% of the cases, GI symptoms that were there, extraordinarily significant. We really now know it has to do a lot with areas where the potential of moisture plays a role. And interestingly and unfortunately, the next largest outbreak of this came here in Pittsburgh at the Vets Hospital. I don't want to get started on VA hospitals and what they've and there have been a lot of problems. This had more to do with the physical plant and things like that. And if you're unfamiliar, the Vets Hospital is up kind of above Pitt, over in the university area, over in Oakland, university area. It's a big old hospital. A lot of people were there. I mean, there's a whole lot depth to the story, but to make it short, this is a gram-negative rod. Very hard to grow because it has to be warm, it has to be moist, it has to be dusty. Okay, doesn't stain particularly well. They named it Legionella because they called it Legionnaire's disease, and pneumophilia because it was a pneumonia causer, like that. Freshwater amoeba, cysts survive, blah blah blah. Biofilms. This is kind of where that happened. If you can think that this was a biofilm that somehow got disturbed, I can't tell you why, but they're sitting in this room, all these, many of them older, 70s and 80s-year-old individuals, all basically inhaling constantly the same air, and they're going to get, unfortunately, this is what happened. So it describes the pathogenesis. 15% of hospitalized cases, so it has a significant fatality rate. My recollection tells me there was an outbreak in New York City because they have a lot of older buildings have like the water, they have like a water, tower is the wrong term, but some type of like water holding big tank sitting on the roof. Something came from that. It's my recollection with regard to that. So it's something you think about, where you might get exposed to this, you collectively, all of us, is if you go to some place like a hotel and they have, we've got we have an inside pool and a hot tub. Watch out for those. You go to one, outside hot tub's not a problem. But inside, if it's not maintained as well as it should be, and there's dust around the area, you got to watch out for that. That's where we've seen a few cases. So that's, a lot of times if you go away, they got a hot tub, let's go, I'll use it. You have to be a little bit cautious to make sure there's adequate ventilation, I think. So originally aerosols from central air systems, nebulizers, showers, water faucets. It's not person to person. By definition, this is not contagious from point A to point B once you have the disease. Okay, antibiotics, beta-lactamase producer, oxygen, really significant. So it's interesting, historically, we thought it was something else. And now we know that's not the, and really this is cleaning, disinfection, humidifying devices. That's the kind of thing I'm talking about indoors. We really have to be concerned about those things. And it's not the only thing, by the way, with indoor hot tubs and spas have a kind of a subset of problems you have to be a little cautious with. You don't see a lot of this. This was a bioterrorism event that occurred about 2002, right after 9/11, shortly, where some disgruntled person working in a lab, I don't know why it was domestic. They thought it was foreign, but it was, had like powdered and weaponized anthrax, where they, in the lab, they can make the capsule smaller so it can get through when you inhale it. And it was like people would open letters, this powder would come out. And several people died. So typically it's livestock, but this is something that has been, and the only people really where we see it in the old days, and this is when I may remember me saying this about anthrax, it was called wool sorter's disease. I mean, now everything's done with automation when they shear sheep for wool and clothing and the fabric industry itself. Back in the old days, they'd sit there and they'd shear the sheep by hand, and you're sitting there inhaling. They didn't have personal protective equipment. That's relatively new. All of those things. If you want, I mean, there are very, very little restrictions on environment and OSHA, Occupation Safety Hazards Administration, like they are now compared. Think of Pittsburgh 100 years ago. The air that you were breathing or were trying to breathe, although it was limited. It was all of those things existed. So that's something you always have to take into account. It's there, but this is what happened. I don't think you'll see it. It's a deadly disease, mind you. So there has to be an index of suspicion with regard to history. And this is good old anthrax. You saw it before. The capsule, endospore former, da-da-da-da. You don't have to go in untreated case fatality 95%. So this is something that people do not want to have. This is an extraordinarily deadly disease. And you can see some of the controls. This was interesting, where these agents were fibromycin, doxycycline, and Cipro, which I talked about, were very, very effective. So sometimes it surprises you. Cipro is usually much better against gram negatives, but for whatever reason, they work very efficiently on this. And the same for doxycycline. Fibromycin is a useful agent, but it's hardly bactericidal, but they happen to work very efficiently against it. So it's interesting. You can't always paint with a broad brush about antibiotics. Finally, the flu. This we're all going to see. It's every year. And the whole idea of this is to understand why it is constantly changing. This is the poster child for RNA viruses. They mutate. Replication of RNA is a very unstable, prone to mutation process. Again, it's the old story. DNA viruses have a great tendency to become latent, and RNA viruses have a greater tendency to mutate. I frame that with viruses, and it doesn't change. And because of these antigenic changes, those mutations in RNA change the spikes. You're going to see it. I'm not going to draw it out. My handwriting's awful. Anyway, these antigenic changes are responsible for the serious annual epidemics that we get. There are two types. The one that we see seasonally all the time, you're going to see, is called antigenic drift. It's subtle changes. They're not really changing. You're taking the same virus, and as it replicates, tiny changes occur over time that change those protein spikes that protrude. And because of that, when we formulate an antibody ourselves, or when we make a vaccine to try to generate those antibodies in us, because of those mutations, the vaccines are considerably less effective. I may have told you, I stopped getting flu shots the one time I used to get one every year, probably from age 50 or 55 on. And then I stopped doing it because the one time I got one, I got the flu. And I said, well, this is not. And I think they have become progressively less helpful. That's my opinion. Years ago, the CDC said flu shots were for the very young, the very old, those at risk, those in healthcare. That's really what the four things. And then they changed the recommendation, and I'm not impressed at all by it. Everybody should get a flu shot, unless there's some reason they shouldn't get a flu shot. It depends on what you think about that, and it really depends on where you're going to work. Believe me, if you're going to be working in a UPMC or a large hospital, corporation hospital, they're going to want you to get the flu shot. They're going to insist, as much as they can insist legally. So that's a whole other subset of problems. It's kind of like being a conscientious objector to having a flu shot. But I don't want to get into the legalities of it or the aggravation that occurs with it. Typically, I think young, healthy individuals can survive the annual flu shot. So typically what happens, we are talking about type A. There's B and C. They're not as severe. So most of the time, that trivalent vaccine, in other words, 3 different strains of flu that are predicted epidemiologically, have to be made. Not last week. The epidemiology comes months in advance. It takes several months to do a run out of these things. So by the time in January they find out it's not working, they're not going to be able to get a new one until April or May, when we really don't need it. So it relies on epidemiological and statistical gathering to determine what the appropriate flu, and hopefully it won't mutate so much it renders it ineffective. That's the song. So there's no, and the stomach flu is a misnomer anyway. That's enteric viruses. You'll understand, we mistakenly said, and I said it before, we mistakenly called, I had a touch of the flu. I'll be back in school on Wednesday. If you had influenza, you are sick. You're going to be in bed 3 days, 5 days, maybe 7 days. You're going to feel lousy for at least another week after it. You're lucky if you get back to work 10 to 14 days after that. I mean, to be able to function the way you used to. It is all about your immune system. The more aggressive that flu is, the more the immunological event is extraordinarily severe. You feel like you can't sit up, you can't get out of bed, you can hardly. And if you had a la the COVID presentation that happened initially, you might have experienced something like that. Very, very severe. Like, oh my God, I can't get out of bed for 10 days. Some people, they can hardly breathe, and all that depends. There was a lot of variations. And influenza is just like that. So understand, it's not, in the old days, my mom and dad called it, oh, you've got the grip. And the grip was like something was holding your chest so you couldn't expand it, holding you in bed. If you got up, you were so dizzy, you had to sit back down or lie back down. Just unbelievably severe. And some years it was more severe than others. That's just the way it is. So, to continue on, headaches, muscle aches, fever, sore throat, fatigue, dry cough, days, incubation for 2 days. The acute, you're in bed for at least a week, and then additional days and or weeks. So we all throw around the term, I have the stomach flu, I've got a touch of the flu. The reality is it's inappropriate if you're talking true microbiology or if you're taking an exam in microbiology. That's the important part to remember. It is an orthomyxovirus. And we're all really just going to focus on influenza A. It's the spikes. You have 7 to 8 identical strands of RNA. Part of what those strands do is they make these spikes. Okay, it's an enveloped virus. It's relatively easy to control in the environment. That's not the problem. The spikes protrude all over this interesting viral particle. This would fall into the realm of pleiform. It's not really isometric. It's certainly not filamentous. It's kind of an oddball. So typically 7 to 8, they're demonstrating 8 in this one. And the spikes are consistently HA, hemagglutinin, or NA, neuraminidase. HA is for attachment. Neuraminidase is critical and release. So, and that's what I mean. When we talked about Tamiflu and Relenza, those are neuraminidase inhibitors. They prevent the release of that virus from budding out. That's why they work if you get to it early enough. So there are a ton of these subtypes, okay? And it's based on, they've identified 18 of the H's when this was published, 11 of the NA subtypes, the neuraminidase, okay? This is incorrect, okay? Whenever they say the word only, I was going to say idiot, but that would be pejorative. Someone who wrote the PowerPoint doesn't read textbooks, doesn't read about it. The worst influenza, that one I talked about in 1919, most people feel was H5N1. So the nonsense that they're writing here about H1, H2, and 3 only, never say only when you're dealing with anything medical. The only you should say, the only and never is that you should never say only consistently. There's a few of those, but they're very rare. Nevertheless, I can remember my middle one had this swine flu in 2009 that was there. Just literally had to carry him out of the emergency room when they finally diagnosed it. And at that time he was 25 years old. So you don't figure young. Sometimes the worst ones to get this are young, healthy individuals because of the immunological response. It's all about that. Mostly because of the undeveloped respiratory and undeveloped immune system, or as your immune system wanes and your respiratory system is compromised, traditionally the people who die of secondary pneumonia or at significant risk with fluid and electrolyte balances are the very old and the very young. But that killer flu of 1918 and 1919, it was all like you, young, healthy individuals. The tragedy, these were men and women who had survived the war to end all wars, World War I, the first mechanized war, a horrible. And they came back surviving it, joyous that they had survived it. And that very next winter, the armistice was signed November 11th, 1918. You might recall my mom's birthday. And that winter, all of a sudden, people were dying everywhere. And they didn't understand this terrible virus that showed up. So, you have to understand the history of this type of thing. And I've made the effort to study it. So there's a lot of information that's there available to it. And you don't have to go through anything crazy about that. The old mucociliary escalator, very susceptible to secondary respiratory infections. Okay. Complete recovery may take 2 months or more. Only a small percentage are fatal, but there are so many cases, the overall number is high. Secondary bacterial infections, principally pneumonia. Epidemics all the time. And again, what is an epidemic? It means it doesn't speak to severity. This is part of that self-study unit. An epidemic speaks to a higher number than would be anticipated based on previous statistics. We know we're going to have, 1 out of every 1,000 people is going to have this. Now we're having 10 out of every 1,000 people, 1 out of 100. That's what defines an epidemic. A greater amount of cases than would be statistically expected based on information that's in here. People, oh my God, there's a pandemic. There could be a pandemic of the common cold. People throw terms around. I hate it. And today in the 24-hour news cycle, every time I see the word Holocaust, genocide, Nazism, fascism, it's for clicks. Sorry to be preachy about that. They throw around terms that they do because it gets people attention. And it's people who write on there and politicians, and they drive me nuts. Okay, epidemics occur annually, pandemics periodically. That's pretty generalized. I'll buy the annually. Pandemics may hopefully a little less than periodically. Drift. Tiny mutations, but they alter those H and N spikes so that antibodies that you might have on board from a previous infection or antibodies that you generated because of an immunization are not likely to work. So the immunity you may have developed if you got it last year, unlikely to be helpful. The shift, that's what allows for this interesting mixture that's scary. And this is the same thing that brought upon COVID. In other words, you have a lot of different animals that get COVID, that get influenza. Horses, a ton of members of the bird family, a ton of members of the pig family, us. There's lots of bats. There's lots of species that get this. The same with COVID. So this isn't something that doesn't have a lot of different hosts. What we talk about in microbiology, it's got a large range. Again, that's not geographic. That's the number of species that it infects. And because of that, and basically this is like the Wuhan for the COVID. This is like any of these things, the farm, where a lot of these things start. You have effectively a farmer, a pig, and a bird all being infected at the same time. And what happens is this genetic reassortment, you end up, even though it's uncommon, with a piece of very unusual, and that's what RNA that creates something we call a novel or new virus. So it gains novel HA or NA antigens to which we have no previous immunity, whether we got it from a horse, a pig, a bat, a squirrel, a skunk, pick one. So they're showing you drift here. Normal, subtle change, but that's how the antibodies attach and immobilize it. Here, you have the classic example of, 3 different potential hosts, and what happens, you end up with some abnormal. So a new variant of a human influenza with a duck end spike. And all of a sudden, be nice to your duck so it doesn't give you a spike. It should be funny. My wife had a pet duck. But you understand what I'm trying to tell you. This is where we get these unusual mixtures that are there. And because of that, they provoke an extraordinarily aggressive response from our immune system. And many of them cause these deadly, at first I would use the term epidemic, but because it's respiratorily spread by coughing, sneezing, that kind of contact, okay, it has a potential of becoming a pandemic. What makes it a pandemic? It crushed an ocean from one continent to another. Again, those terms don't speak of the potential death that could come from them, if there is any. It doesn't talk about mortality and morbidity. Understand what terms mean. People use them to scare. Knowledge is power. So, influenza A appearances are found in birds. Here's one that occurred, a Hong Kong variation, chicken spread to human. H7N9 avian virus appeared in China, 30 to 40% case fatality rate. No human cases that we know of. Again, a possibility it could change. Here, antiviral medications if you catch it early. This is interesting. You will hear about, I don't know how you pronounce it, Ray or Rise syndrome is a fatal liver disease. We do not know exactly what causes it. Do not give aspirin. There are very few indications for aspirin in children. Tylenol and ibuprofen, okay. Tylenol is very dangerous stuff if you give too much of it. Most long-term liver damage in children comes from overingestion of Tylenol. So you have to be very, very watchful of that. But aspirin is contraindicated, and I would say 15 at a minimum. Maybe in the old days we thought it was 18 because they used to use it for the measles and mumps. We only had aspirin. Tylenol didn't come out until 1955. I think I got those diseases in 57. Most of the households we had aspirin. Like Tylenol was new. And we didn't know about all this stuff. Maybe that was helpful. But nevertheless, what goes on with regard to this, you must be. Because if many of you are going to healthcare, people are going to come to you and go, oh, my kid's sick. What should I give him? He's got a high fever. Do not be very, very alert. Not just to aspirin, but things that contain aspirin. Excedrin has aspirin. It's got aspirin, it's got acetaminophen, which is Tylenol, and it has caffeine. Understand the pharmacology. I hate to be preachy, but I think it's really important to understand what's going on with that. So, I mean, when people come to your advice because you're going to be a professional, those three little words work a lot of times. I don't know. But you can find out. But this is something that's very, very rare. It's not just influenza, any febrile disease. If they, even though we're immunized, they still occur. So that's everything about this. It's really an important area. RSV. There are now the three big players. You go to one of these urgent care places or an emergency room and you're coughing, oh, I got the flu. They're going to test you for three. They're going to test you for influenza. They're going to test you for RSV, respiratory syncytial virus, and they're going to test you for COVID. Because their presentations are very, very similar. They're not all the same. We have. So understand, in the absence of someone being positive for influenza or being positive for COVID, mostly they have RSV. We didn't used to see as much of it now, but it's become very, very significant in the very young and the very old. My late mother-in-law died slightly more than a year ago. I mean, really the two significant, as she got toward her later years, let's say from 95, she was 98 plus when she died, 98 and a half. Turned out to be RSV. And that was I think that was really, that really set the downturn more than anything else. Very, very difficult breathing, bad color, okay? For you and I, okay, it's really similar to a bad cold. Croup. Croup is that sound that's very much like whooping cough, but not nearly as severe. It's typically, we're getting past the stage of infants, which they start to get to be toddlers and a little bit older. Typically, it presents as croup, which is relatively easy to deal with. Okay. Okay. So that's one of the things we do. So getting RSV, for the most part, in your age bracket, would just require, normal supportive care. I don't think there's any antivirals that people would employ. It's basically going to take X amount of days and you'll get better. The cough may linger. So again, that's a paramyxovirus. It's a little different. That's the same family with measles and mumps. The pathology, and this is the way sometimes viruses work, they cause a syncytium, a fusion of cells. You should be familiar with the term syncytium because you have A and B, which is the heart. All the cells are effectively fused together because the heart is a unit. That's a bad thing. Good thing for the heart, bad thing for the lungs. Okay? And very, very significant problem. All the things you can see there, potentially very dangerous. And again, secondary bacterial pneumonia. Certain times when we see it, we're just basically getting out of that. Okay? Healthy treated adults usually have a mild illness, but are able to spread the virus. So it's not unusual. Typically, I would think that it's one of those things when it's mostly cough and feeling lousy. And if you have one of those home COVID tests and it's negative, the severity of the cough, I'm thinking RSV, particularly if it's mild fever comparatively. And there really is not an effective antiviral for that. Okay. No vaccine. I mean, I just don't think there's anything really you can do about that. And again, I would shy away from thinking that there's going to be immunizations that are going to be helpful coming in the future. Hantavirus. It's more common than you think, but less so around here. Remember, we see it particularly in those four corner states in the desert Southwest because it's aerosolized and stays in the air, just like tuberculosis, in that dry, arid, and it comes from rodent droppings, that dry, arid environment. So this was one of these outbreaks that they're talking about. We saw it again. You can see it in the Korean War. Pretty severe. Back in England, if you remember the story of the Pied Piper, if you don't, basically they brought somebody in, so because the rats were troubling them, and it's obviously this fun little tale that you tell, and he used the Pied Piper and this little English town. He got all the rats to jump into the river, and they all died. Well, they wouldn't pay him. Then he did Pied Piper and all the children. And he pulled away until they paid him. That was the story. But the reality was they were very aware that rats became a problem. In England, they had something called the sweating sickness. That they defined in Tudor England in the 1500s. This is most likely what it was from. They didn't understand how it was transmitted, but because rats were everywhere, I mean, it's all about sanitation. That's there. Very, very severe shortness of breath. Death came fairly quickly. They identified the virus. Again, it's an enveloped virus. Infects rodent species, but does not appear to be harmful to them. So, dust contaminated urine, feces, saliva of rodents. Very severe inflammatory response, high death rate. And person-to-person transmission is relatively low. So it's something, depending on where, again, I'd be more attuned to this if you end up going to the Valley of the Sun, in the Arizona, New Mexico, that neck of the woods area that's there. Okay? Increasing mouse populations in poor communities and substandard housing, that's a potential that you have to be looking for as well. Not a whole lot of treatment. It's more about the exposure that's there. Urban environments really pose a whole subset of problems, which we certainly don't reside in one here. Pittsburgh they've gone away from the typically high-rise tenements or low-income housing that used to be all over the place. I've seen a lot less of it, and I think a lot of it had to do with my late former brother-in-law. My first wife brother was a rat control officer, worked for the city for a number of years, part of the sanitation department. And we would go around and monitor and put traps in all these old buildings. Not easy work. So, many, many years ago, probably good 50 years ago. So you can see all the things that are associated with it. SARS and MERS. These were our coronaviruses. that rear their heads pre-COVID. Okay, coronavirus, COVID, coronavirus, and indeed SARS CoV-1 is what was the original severe acute respiratory syndrome. MERS, you'll see, is Middle East respiratory syndrome. So this developed itself here, a number of cases, a number of deaths. What happened is somebody who was infected got on a plane. I think it was coming from, I'm going to guess, Japan, and made its way to like Toronto or Montreal. And on a plane, it was effectively a super spreader event that we used to call them, and probably still do. And so in that way, it became very rapidly identifiable. And that's with regard to the spread. But it was an isolated thing. Everybody was on the lookout. MERS, Middle East Respiratory Syndrome, this ended up spreading, but this came coincidental to a lot of the wartime, the armed conflict activities that were occurring in a variety of campaigns in Iraq. Different surges, whatever the operation names are, they escaped me. But this wasn't that terribly long ago. And so all of these types of things, very similar but not as severe as COVID-19, but they were all coronaviruses. Coronaviruses up until then were basically cold viruses. What happened? Same thing that happened with influenza. They became novel viruses, getting RNA in them that was different than the RNA we were used to. Okay, it got its name from the crown-like appearance of the protein spikes. Cytokine storm, exactly what COVID-19 was about, likely originated in bats, just like COVID-19, super spreader oriented, okay, that kind of things. Again, not a lot of treatments that were there at that point in time. So that when this was written, it didn't have a whole lot about it. For the sake of completion of the PowerPoint, this is something, again, in the Southwest, because of the dry, arid, this is fungal. It used to be called San Joaquin Valley fever. Now we just call it valley fever. A lot of people are exposed to it. It affects animals as well. My brother-in-law lives in Tucson, has been there for many, many years, retired from the Air Force. There, I mean, he's the most in-shape 75-year-old guy I ever saw. And he hikes and all those things, but they've had dogs that have gotten, and it's not uncommon for this to occur, but they're aware of how to treat them. And it's one of these fungi, we call them dimorphic. They can be either yeast or mold, and they get into the lungs, and they use the term spore, but they're not endospores. That's there, and they do have to be treated, but there are useful antifungals today. Okay, semi-dry or arid areas, they have to be particularly utilized for an appropriate period of time. And the other one we see more in moist areas. This is probably in Arkansas, Tennessee, North Carolina. Spelunker's disease, caving. Again, the association with bats and droppings may play a role, but this is also fungal. And again, these are all, so you have to understand when you're going to certain areas or doing certain activity, what the risks are. And I would make you aware of that just because it's part of this chapter. You can see the epidemiology where it is. Again, a lot of caving areas that are there. Bat droppings are usually a way that it is carried. You know, a lot of people have been exposed in these particular areas. Thankfully, not so much around here, though we do have some caving that goes on. I mean, here we have one that's fairly close. They just made a national park over there outside, right by Uniontown. But I mean, in the central portion of the state, they have those as well. And this is the one that defined AIDS, PCP pneumonia, way back in the day, back in 1981. They saw it, but it really isn't. It's an opportunistic. It's something your immune system and my immune system would take care of fairly easily. It's there, but yet this was the pneumonia that they saw this outbreak in San Francisco that defined AIDS. Okay, and really defined the idea of HIV becoming AIDS. It was once known as this. Now they call it pneumocystis jirovecii, but it used to be called pneumocystis carinii. That's the name. PCP, PC, and the other P was for pneumonia. And I wanted to give you that for the sake of completeness. This gives me the opportunity to go back at least to do the time we have left today. The chapter 19 in Cowan, the textbook chapter from your textbook that has, and it has very, very similar information, as you can see, with these different kinds of pneumonias. And you should have a little nugget about COVID very shortly. Same thing, and shift and drift and all that type of stuff that are there. Whooping cough, TB. You should be here somewhere. Don't let me lose you. I lost you. I know I saw the word COVID before, but I'll keep going backwards. I will find. They have a COVID chapter, so I'll give you. I thought it was in here, but I may be wrong about that. But I will find it for you and present that. I'll give it to you on Monday because I think it's important. But in the time we have left, I'll just describe it. Again, it was a novel virus. And it's not, I mean, this is not something I'm going to test about the origins because it's uncertain. But there's several prevalent theories about it, none of which we will know probably in our lifetime. I mean, I really just think these are the kind of things that somebody has an idea about it. But we were, what they've told us is there's an open air market in a giant city called Wuhan. It just happens to be where a lab that was experimenting with COVID viruses in a joint venture from our country as well as China. Was it a lab accident? Was it an intentional release? Was it just something that occurred in this market where there's animals everywhere, living animals? They slaughter them there. You can only imagine what it's like in this very, very crowded area. Long story short, a coronavirus, a la what happens with these novel viruses for influenza, appeared. And you can trace its origin to that city where we first saw the numbers. It was clearly a coronavirus. It had a variety of species, including bat, when they analyzed the RNA that was in that viruses. So it's different, and even though it's just one large RNA sequence, you could analyze it genetically and find out that these were genetic pieces from different animals, including bats. So it's a novel virus, and they named it SARS-CoV-2, and we called it COVID-19. And what it did, when it entered your lungs, it attached itself to receptors in your lung. Did you get to renal yet? Just doing it now. Did you in your studies, did you hear about the renin-angiotensin-aldosterone mechanism? It's something called angiotensin converting enzyme 2. There is a receptor for this angiotensin converting enzyme in an angiotensin 2 receptors in your lungs that are your friends. They're really an important part of, and what happened is this virus attached to these receptors and altered them. Rather than make things that reduced inflammation, they produced massive amounts of cytokines that were pro-inflammatory. And that's where the saga began and caused a devastating amount of changes. That's kind of the sort of internal pathophysiology of that particular virus. It's scary. Very, very scary. We didn't understand it because it was novel. It had devastating effects. And at that point, it was rapidly transmitted. And I mean, I don't buy all the numbers that are there. Like I said, everybody who died, if they tested positive for COVID, it's COVID-related death. 100-year-old person dies because they're 100 years old. The fact that they have COVID doesn't mean they died from COVID. It's a concomitant finding. I'd buy that. But I mean, understand they're selling vaccines. Make a lot of money for a lot of people. It did. And it wasn't innocent. And I don't want to get into the whole behind it, but you need to know about these things going forward. because it's not going to be the only one that you're going to see in your lifetime. I have very strong feeling about that. But nevertheless, that was the problem. And what happened predictably is that it has mutated and it continues to mutate. It becomes relatively easy to transmit, but much more like having a bad cold or a flu. It really does. So the signs and symptoms have become much less severe. The risk of death has become much less severe unless you're already at risk. Immunocompromised, very old, very young. I mean, those are still things that exist, as they would with any viral respiratory infection. But what's happened, that's really what it has morphed into that. And that's relatively quick with all these different, we have a new Delta strain and Beta strain. They're becoming less and less problematic. Are they a problem? Yeah. Are they killers? Probably not the same. So I'll leave you with that because our time is up. See everybody Monday. If there's any little nuggets I've forgotten, I'll either record it and send it to you because I'm going to start skin on Monday. Next week it's going to be skin infection week. The week after that it'll be genitourinary, and our last week will be wound infections. Have a great weekend. Thanks for being here.